This is a 6th grade chapter 7 test review. And the first problem says evaluate the expression if a equals 2, b equals 5, and c equals 1/2. Number 1, a plus 12c. So I'm going to replace a with 2 plus 12. When I have a number next to a letter, that means I'm going to multiply. So I'm going to do 12 times c is 1/2. All right, and then when I'm working out a problem like this, I want to make sure I'm following the order of operations. So I have adding and I have multiplying, and PEMDAS tells me that I need to multiply before I add. So I'm going to multiply 12 times 1/2. In order to multiply times fractions, I need to make the 12 a fraction. So I'm going to make this 12 over 1, and then top times the top and bottom times the bottom. All right, so 12 times 1 is 12, and 1 times 2 is 2. So now I have 2 plus 12 over 2. I'm going to go ahead and simplify this. So I can think of this as Tybo, top in, bottom out. So 2 will go into 12 6 times. So this becomes 2 plus 6. And now I can go ahead and add that to get 8. All right, number 2 is b to the 2nd power. An exponent like this tells you how many times to multiply the base. So b to the 2nd power doesn't mean 2 times b, it means b 2 times. So I'm going to multiply b times itself. And since b is 5, I'm going to multiply 5 times 5, which is 25. Right, on C, I have AB. This is just like a number next to a letter. When you have those two together and you don't see an operation, it means you multiply. So AB means A times B. And again, A is 2, that's from up here. So 2, B is 5, so I'm going to say times 5. And then minus A is 2. All right, so again, I'm going to multiply before I subtract because multiplication comes first. So 2 times 5 is 10. And then 10 minus 2 is 8. On number 4, for B, it tells me I'm multiplying 4 times B, and B is 5. Minus, then in parentheses, I have 20C, so that would be 20 times C is 1/2. Plus A is 2. All right, so I'm going to take care of what's inside the parentheses first. This parentheses I'm just using as multiplication, so there's not really anything to do. So I need to jump over to this set of parentheses. And then this set of parentheses, I have multiplying and adding. So multiplying comes before adding in PEMDAS, so I want to start with that. I'm going to make this 20 over 1, multiply top times the top and bottom times the bottom. So I'm going to get 20 over 2 plus 2. And over here I still have 4 times 5. All right, I want to simplify this. 20 over 2, that's just a division problem, top in, bottom out. 2 will go into 20 10 times. So now I have 4 times 5 minus, in parentheses, 10 plus 2. So I'm not quite done here. I still need to add 10 plus 2. So I have 4 times 5 minus 10 plus 2 is 12. Now I want to multiply and then subtract. So 4 times 5 is 20, and 20 minus 12 is 8. All right, number 5, it says Sophia has $32 to spend on her sister's birthday present. If she buys 3 DVDs at $D per DVD, she will have 32 minus 3D of her money left. How much does she have left if the DVDs cost $8.75 each? All right, so they've already given me the expression to use, 32 minus 3D, meaning 3 times D. And D, it tells me, is the number of dollars per DVD. And then it says, how much is she going to have left if the DVDs cost $8.75? So that tells me to replace D with $8.75. So I need to do 32 minus 3, and then that means multiply times $8.75. I have subtraction and multiplication, so I'm going to start with my multiplication. 8.75 times 3, I'm putting that on top because it has the most digits. So 3 times 5 is 15, carry your 1, 3 times 7 is 21, plus 1 is 22, carry your 2, 3 times 8 is 24, plus 2 is 26. And then I have 2 decimals here, so that means I'm going to have 2 decimals here, so that's going to go between the 6 and the 2. So now I have 32 minus $26.25. In order to subtract these, I need to line up my decimal. Because the 32 doesn't have a decimal, I'm going to add the decimal and make it 32.00 so that I can subtract 26.25. I can't subtract 5 from 0, so I'm going to need to borrow, but I can't borrow from the 0, so I have to go to the 2. makes that a 1. And that makes this a 10, but I have to borrow from it, so now it's a 9. And then this becomes a 10. All right, so 10 minus 5 is 5. 9 minus 2 is 7. Again, I'm going to need to borrow in order to make this more than 1, so that becomes a 2. Now this is an 11. 11 minus 6 is 5. And then with subtraction, the decimal comes straight down. My final answer is $5.75. On 6, it says first to define a variable and write each phrase as an algebraic expression. So I know algebraic expressions have to have a variable, which is just a number, and an operation, which is adding, subtracting, multiplying, and dividing. 1/6 says 1/3 the number of cards Louise has. So I'm going to look for keywords first. This helps me identify the operation. And I would say the keyword here is 1/3, which means divide it by 3. So now I have to figure out, what am I dividing by 3? Well, it's the number of cards Louise has. So this is the part I don't know. That's the part I'm going to that's the part I'm going to name as a variable. I'm going to use C for cards. So I would say C, the number of cards, divided by 3. And that's my answer. Now, 1/3 to S tells us to divide, but I could also write this as a fraction, 1/3 C, like this. Or I could also write it as C over 3, because I know that division can also be used, can also be expressed as a fraction, right? Because I don't have a division sign on my computer, so I always write it like this. And then that actually is the same thing as a fraction here, which is also the same thing as just saying 1/3 C. But most likely on your test, you would see something like this. C divided by 3, we want you to recognize 1/3 means division. All right, number 7, 4 miles less than Katrina ran. So less than is my keyword right here. It's telling me to subtract. So what am I subtracting? I'm subtracting 4 miles from what Katrina ran. So I don't know how many Katrina ran, so she's going to be my variable K. But I know that whatever I'm solving for is 4 less than that. So that's not 4 minus K, that's K minus 4 miles, right? Less than's tricky because it changes. You can't just do it in order. You're actually starting at the back and working your way forward. All right, on number 8, it says 1.25 times as many chapters read. So times is my keyword. It tells me to multiply. I'm multiplying 1.25 times however many chapters. I don't know how many chapters. That's my variable. So I'm going to call it C. And I don't need any operation here because I can just put the number next to the letter, and that tells me I'm multiplying. Now I could have written in parentheses. I can use a dot. But as we get closer to algebra, this is the way you're going to see multiplication written. So that's the way we want you to try it. All right, on number 9, it says 3 inches greater than triple Anisha's height. Okay, and triple is also a keyword. So greater than is telling me to add, but triple means I'm multiplying, and not just multiplying, but multiplying times 3. All right, Anisha's height is what I don't know, so that's my variable. This kind of problem, it's helpful to start at the back and work your way to the front. So what I'm doing is I'm tripling Anisha's height. So that means if Anisha's height is h, and I want to triple it, I have to say 3 times h, or 3h. If I want to be 3 inches greater than that, I'm going to add to that 3 inches. So 3h plus 3. I can't add these together because this 3 is without a variable. So this is just going to stay 3h plus 3. Now you may use a different variable, and that's okay as long as you have 3 times that variable plus 3. Number 10, William had 6 bags of jelly beans. Each one weighed the same number of pounds P. Then he bought a box of jelly beans that weighs 10 pounds. So write an expression that represents the total weight of the jelly beans that William has. All right, so this tells me he's buying 6 bags. So if I just want a picture of what this looks like, he's got 6 of these little bags full of jelly beans. They're each the same, even though my drawing does not make them look all the same, but there's 6 of them, 6 bags. And these are all P pounds. Then he buys a box that's 10 pounds. Okay, so we've got 6 of these and we don't know how much they are. but we're going to call them p, so 6p's, or 6 times p. And then I'm going to add to that the box, so plus 10, to get the expression 6p plus 10. So that's his total weight. That's probably a lot of jelly beans, I don't know. Okay, number 11. Lily purchased 8 paintbrushes for $4.59 each and 12 jars of paint for $3.85 each. Write an expression for the total cost of the art supplies. So she's got paintbrushes. That's supposed to be a paintbrush. These are $4.59, but she bought 8 of them. So I need to multiply 8 times $4.59. Okay, then she buys a jar of paint. This is supposed to be a jar. Okay, and then it costs $3.85, but she buys 12 of them. So I need to multiply 12 times $3.85. And if I add these together, that's going to be my total cost for the art supplies. So this is the correct expression that I need to use. But to find the total cost, then I need to go ahead and finish it up. So 8 times $4.59. I need to multiply. 8 times 9 is 72. 8 times 5 is 40, plus 7 is 47. 8 times 4 is 32, plus 4 is 36. I have 1, 2 decimals, so 1, 2 here. And I'm going to do the same thing with 12 times $3.85. So 2 times 5 is 10. 2 times 8 is 16, plus 1 is 17. 2 times 3 is 6, plus 1 is 7. Start with a 0, 1 times 5, 1 times 8, 1 times 3. Add those up, 0, 12, that's 15, 16, and then 4. There's 2 decimals here, so 2 here, $46.20. And then I'm going to go ahead and add these two now together. So if I add, running out of room here, 36, 72, I'm going to line up my decimals, 46, 20. 2 plus 0 is 2, 7 plus 2 is 9, 6 plus 6 is 12, 1 plus 3 is 4, plus 4 is 8, and then if I drop the decimal down, like I do with addition, I get $82.92. So my final cost is $82.92. All right. On number 12, I want to generate an equivalent expression using the distributive property. So distribute means to sort of pass out. So I'm going to draw arrows to remind myself that I need to distribute the 7 to both of the terms inside the parentheses. So that would be 7 times 2w. So I'm going to write that 7 times 2w plus comes from inside the parentheses, and then I'm going to do the same thing again, but this time times the 9, 7 times 9. And if I go ahead and work this out, 7 times 2 is 14, so this becomes 14w. And then 7 times 9 is 63. Keep the plus sign. I cannot add these together because one has a w and one does not. So this will just stay 14w plus 63. On 13, the number outside the parentheses is 11. So I'm going to multiply times both of these terms. 11 times 6c. That's what I'm going to write down. 11 times 6c. I'm going to use the plus sign. And then 11 times d. And if there's not a number, remember, inside or in front of that variable, then we can think of that as a 1. So I'm going to multiply times 11 times d, or 11 times 1d. 11 times 6 is 66c. 11 times d, or 11 times 1d, is just going to be 11d. And then I keep that plus sign. Again, this is like 66 cats and 11 dogs. I can't add those together, so it's just going to stay. And then 14, I have another distributive property. This time they put the 5 in the back. Doesn't really matter. If you want to move it to the front, you can, because multiplication is commutative, so we're allowed to switch the order. Or you can just distribute from the back, and it's the same thing. So I'm going to multiply 5 times 2x, and then here I'm going to multiply 5 times 3y. And I'm going to keep the minus sign in between this. If I did it this way, 5 times 2x and 5 times 3y, I still have the exact same thing. 5 times 2x, 5 times 3y, I still have the subtraction sign. So nothing's changed. But if it bothers you to see it in the back, you can always rewrite it. Then go ahead and work these out. 5 times 2 is 10. 5 times 3 is 15. Keep the x, keep the y, and keep the subtraction sign. Again, I can't put these together. They're different animals, X and Y. So I'm going to leave it like this. And number 15, I am simplifying each expression. So I'm going to look for terms that have the same variables. So again, we could name these different animals. So if I have 5, let's say yaks, I want to look to see if there are any more yaks here. So I have 5 here and I have 2 here. So 5 plus 2 yaks would be like 7 yaks. But I can't add this to Z because that's like adding yaks to zebras. They're different animals, so we keep them different. So this is just gonna stay a Z. So 7 yaks plus 9 zebras. All right, that's my answer. Number 16, I'm starting with 12H plus 3J minus 4H minus J. So I have 12, let's say, horses here. I'm looking to see if there are any more horses. I can see that there are horses right here. So I have 12 horses minus 4 horses. And this is subtraction because I have to keep the sign that was with the 4. So this is 12 minus 4, which would just be 8H. And then I'm going to go back and see if there's anything else. So I have a 3J, so I can think of that as 3 jellyfish. And it's positive because of that plus sign in front of the 3. So do I have any more jellyfish? Well, I have one here that I need to combine it with. So plus 3J minus J. And so I'm subtracting these. This one doesn't have a number, but remember, if there's not a number, it's automatically just a 1. So that's like having a positive 3 minus 1, which is just 2J. And it's a positive 2J, so I'm going to write plus in front of it. So now I have 8 horses plus 2 jellyfish. I can't simplify that anymore. So that's my final answer. On 17, I'm going to start with 4W plus 3 plus 8W minus 2Y plus 5. So if I can think of 4W as what? 4 whales. Do I have any more whales? If I look at the rest of these terms, I can see there's 8 right here, and it's plus 8W. So I'm going to be adding these two numbers. 4 plus 8 gives me 12W. The next thing I have is just a constant, plus 3. So I'm going to look to see if there are any more constants or just plain old numbers. That's what that is. So I have a plus 3 here. That is not a constant because it has a y, but the 5 is. So I'm going to add plus 3 plus 5 here because I'm keeping the plus signs with both of these numbers. And that's how like having a positive 3 plus 5. Well, 3 plus 5 is 8, and it's positive. So I'm going to put a plus sign in front of my 8. So 12W plus 8. And then I want to go back and make sure I've used every term, and I can see that the one I haven't used yet is the 2Y. And there are no more Y's, so this is just going to be part of my expression. I'm going to keep the minus sign with the Y. All right, so 12 whales plus 8 minus 2, whatever, yaks. All right, on 18, 9 friends went out for pizza. The price of a slice of pizza was $2. Each of them bought 1 slice. 7 of the friends also bought a drink for $2. Write and simplify an expression that represents the total cost. All right, so I have 9 pizza. They're each going to buy a slice of pizza. So that tells me there's 9 slices of pizza, I guess. These are supposed to be pizza slices. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, but the cost of each of these is P. These are all P's. Okay, and I just said I have 9 of them, so I can write this as 9P. All right, and then each of them bought 1 slice. They each just got 1, so that's a total of 9. 7 of the friends also bought a drink for $2. So I've got 7 of these drinks. Yep, that's 7. And this time I do know how much they cost. Each of these are $2. So that's 2, that's 2, that's 2, that's 2, that's 2, that's 2, that's 2. All right, so I have 7 of these total. So 7 times 2 is what I need to add to my slices of pizza. And then I can go ahead and work that out. 7 times 2 is 14. So I have 9 pieces of pizza plus $14 for the drinks. Since I don't know how much the pizza costs, then I just have to leave it as 9p plus 14. All right, on 19, I need to change $3 and $3 and 12/25 into a decimal. So when that happens and you have a mixed number, the whole number goes inside your answer box. And it's really just the fraction that I'm changing into a decimal. So I'm going to do that by using Tybo. So the top comes in, the bottom comes out, 25. I cannot divide 25 into 1 or 2. So now I'm going to add a decimal and a 0. Bring that decimal up. And so now I'm thinking of 25 into 120. And 25, if you compare that to quarters, maybe think about how many quarters it takes if this were $1.20. I could do 4 quarters would give me $1, so 4 times 25, it's like 100. When I subtract, I get 20. So I need to keep going, add a 0, and bring it down. So 25 will go into 200. That's kind of the same thing as how many quarters go into $2? 8. 8 times 25 is $2 or is 200, and now I'm done. This is 0.48, so I'm going to put this with the rest of my answer. And so the whole number stays a whole number, and 12/25 has become the decimal 0.48, so 3.48. And then arrange in order from greatest to least, so I want to pay attention to that. And I have 3 numbers here I need to arrange in order. I'm going to change everything to percent, because for me that's easier to put things in order if they're all percents. They definitely all need to be the same thing. I prefer percents. So to change a decimal to a percent, I want to remember FDP. I'm starting here and I'm going to percent. That's direction that my decimal moves 2 places always. If this moves over 2 places, it becomes 7%. 71% is already a percent, so it doesn't need to be changed. And then 7/10 I need to change to a percent, but I'm starting as the fraction. So to change a fraction to a decimal, first I need to divide or Tybo. So top in, bottom out. Can't divide 10 into 7, so I'm going to bring my decimal up and add a 0. 10 will go into 70 7 times. Okay, so I have the decimal 0.7, but now I still need to change it into a percent, so I'm going to move it 2 places over. And when I do that, I have to add a 0 here in order to move it 2 places. So this becomes 70%. So now I need to put these numbers in order from greatest to least. So greatest means I'm starting with the biggest. So that's going to be 71%, then 70%, then 7%. I always want to rewrite it in the same form they gave it to me in. So 71% started off as 71%. That didn't change. 70% was first a fraction. That was 7/10. And then 7% was originally 0.07. So this is how your answer choice would be written. Okay? Greatest to least. Make sure you pay attention, because if they switch that up, then we would be using this part right here. All right, 21 says arrange in order. This time it is least to greatest, so now I'm starting with the smallest and going to the biggest. So I have several numbers here. Some are negative, some are positive. Negative numbers are definitely smaller than positive numbers. But remember, on a number line, the negative numbers, as they go to the left, the number itself is bigger, but the value of the number is smaller, because it's like you're getting more and more in debt. All right, so actually the one that's furthest this way would be -10, and then the numbers get a little smaller as they approach 0. So that would be -6, then -3. And then once you pass 0, positive numbers are easy to put in order because they're how we were taught. So then the +3, the 7, and the 9. All right, so if drawing a number line helps, you can do it that way. Otherwise, just rewrite them. -10, -6, -3. And then 0 wasn't one of my numbers. I just added it to my number line, so I'm not going to put that in my answer. But then I'm going to skip to 3, 6, nope, sorry, 7, and 9. Okay. All right, and then these last 4 problems are just for you to practice and putting numbers on a griddable, because you do have at least one of these on your test, so we want to make sure you know how to fill them in. When it's a decimal, most of you are doing pretty good with those. You're just going to write the number in front of the decimal, and the number behind the decimal, okay, and then bubble in the numbers that match up with that, so the 6 and the 7. Notice over here you have positive and negative. And as long as the number is positive, you don't have to fill this in. If you want to fill it in, you can. You could put a plus sign here and fill in the positive. But you definitely don't have to. The only time you have to fill out this column is when the answer is negative. If you leave it blank, they're going to assume that you mean a positive number. Same thing with the zeros. You don't have to fill in any of these zeros. You can if you want. It's not wrong, but it's not something you have to do. Unless it's part of your answer. So if this were like 6.07, then I would need the 0. All right, so for B, I just have a whole number, 81. So this, sometimes people are getting confused with this one because they want to put the 81 over here. But that's not the same thing. 81 is not the same as 0.81. Okay, that's like changing $81 into 81 cents. So I don't want to put it over here. 81, if I was trying to change this into $81, my decimal would be over here. Okay, so that's definitely how I want to think of it when I bubble it in. So the 81 is actually in front of the decimal because it's a whole number, not a decimal. And then I would go ahead and fill in the 8 and the 1. Okay, again, I don't have to have zeros. I can if I want. It's positive, so I don't have to mess with this part right here. All right, for 0.92, this is coming after the decimal, so I would fill it in after the decimal and then bubble in the 9 and the 2. It's positive, so I don't have to do the positive. I can. Sometimes people put a 0 here and bubble it in. That's perfectly fine. It is not necessary. You could do all the zeros if you want, or you could do none of them. All right, as long as you get the 9, 2 correct, then that's really all they're looking for. And then D is a negative whole number, so negative, because this is negative, I have to do this part over here. And then I would fill in the negative right here. Okay, notice I'm writing the negative all the way on the outside. 12 doesn't have a decimal, but it is a whole number. So if I put it over here, I'm making it a decimal. I do not want to change 12 into 12 cents. That's different. It's like changing $12 to 12 cents. So $12, whole number has a decimal in the back. All right, so that means I want the decimal here. I want the 12 in front of it. All right, notice these are not right next to each other, and that's okay. This is the part for the sign. This is the part for the numbers. And then I'm going to fill in the 1 and the 2. Okay, can you put the zeros? Absolutely, but they're not necessary. Okay, that's it for Chapter 7. Hopefully you'll do well on your test. I'll see you soon.